Good morning, dear students. So, this class is going to be specially for MTech, not for the BTech. Okay, it is about the environmental chemistry part. I'm very sure that many of you who have come across BTech are not very serious about environmental engineering, and we engineers loves to have the chemistry part. But without chemistry, it is not very easy for environmental engineering. So, this chemistry part is not very high, but at least the minimum you have to know for physical balance, chemical balance, whatever. So let me give a little bit of introduction. This is for CE 501, okay, for environmental chemistry part. So to begin with, first, let me say one thing. In environmental engineering, the concentration is a very, very, very important topic. Okay, so in environmental concentration is very important. So what we do is some of the expression we have are number one is milligram per liter. That means how much milligram of the solid is present and how much liter of the solid. Number two is ppm. Okay, see over here, ppm means 1 part in 10 to the power 6 part. 1 in a million, parts per million. 1 in 10 to the power 6. So you can say 1 milligram is present in 10 to the power 6 milligram. So this can be said as 1 by, so this is 10 to the power 6 milligram is 1 milligram in a 1 kg. Okay, and 1 kg is nothing, it is 1 liter. So can I say that 1 ppm is nothing, is equal to 1 milligram per liter. So these two denotations are having same meaning. Okay, this is number one. Number three part, 1 percentage. Sometimes you must be remembering we said percentage. Dextrose 5%, dextrose 10%, sodium chloride 10% when we try to put for injection or whatever. Okay. So percentage means what? It is 1 milligram in 100 milligram. That is 1%. Okay. So to make this one in kg so that we can convert into liters, what we do is 10 to the power 4 milligram by 100 into 10 to the power 4 milligram. So the lower part becomes 10 to the power 6 milligram and upper part is 10 to the power 4 milligram. Is equal to, can I say, 10 to the power 4 milligram per liter, or it is also called 10 grams per liter. So 1 percentage is equal to 10 to the power 4 milligram per liter or 10 grams per liter. So what is 10? What is 5% of glucose? Oh, sorry, 5% of sodium chloride means. One example is 5%. Say sodium chloride means 5% is 5 into 10 to the power 4 gram of sodium chloride is dissolved per liter. Okay. So 5 into 10 to the power 4 gram. Sorry, milligram. So this is nothing, 50 grams. If you dissolve 50 grams in a liter, that is called 5% of sodium chloride. Okay. I think concentration concept is clear. The next one is a topic which many of you feels really uncomfortable with. Many of the environmental engineering new fresh students, that is the concept of molarity and normality. Okay. Next one is the topic where environmental engineering, this one is concept is very important. That is one molarity. You don't have to get a headache too much. You don't have to worry. One molarity is also a concentration. Milligram per liter, ppm, percentage, molarity. These are all different sorts of concentration. Okay. One molarity means when you dissolve one molecular weight of a substance in 1 liter. This is called one molarity, okay, or 1 mole of a substance. Now, for this, you have to remember some of the molecular weight of some substance in environmental engineering. Say carbon is 12, oxygen is 16, hydrogen is 1. Means carbon molecular weight is 12 gram, 16 gram, 1 gram. Then sulfur 32, nitrogen 14 grams. Then what else? Phosphorus 39 gram. Some of the common thing: sulfuric acid H2SO4, nitric acid HNO3, hydrochloric acid HCl, chloride is 35.5, but sometimes you can use as 36 lump sum. Okay, so these are some of the things you have to remember. And then calcium, because of hardness, calcium is 40 grams, magnesium 24 grams. So only few you have to remember. You should not have the apprehension that the moment you open a textbook, oh, this chemistry is coming, I got completely pissed off. No. These are only few elements that will come in environmental engineering. CHO, because organic compounds, sulfuric acid, nitric acid. P is important because it is going to give the structure of biomass, the nutrients. Chloride, hydrochloric acid, chlorination, calcium, hardness, magnesium, hardness, right? So only this few you have to remember, nothing much. Now, if I say, what is 1 mole of sodium chloride? I missed it, sodium, right? Sodium is equal to 23 gram. Okay, so 1 mole of sodium chloride means you take 23 gram of sodium plus 35.5 in 1 liter, that is 58. Dissolve 58.5 grams of NaCl and in 1 liter. This is nothing 1 mole NaCl. Is it okay? Clear? Okay. Now, if I say 1 mole, say for example, this is 1 mole. If I say 0.2 mole NaCl, this is another example, then it is nothing. It is 0.2 into 58.5 grams of NaCl in 1 liter. This is equal to 210, 1 kg, 2 16, 7, 1 kg, 210, 11. So that is 11.7 grams per NaCl. This solution is going to give 0.2 moles of NaCl. Okay. So if I say 1% of sodium chloride, that is 10 grams per liter of sodium chloride. If I say 1 mole of NaCl, then it is 58.5 grams dissolved in the 1 liter of the water. Is that clear? So this is all about the molecular weight concept. This is very important for many of you to remember. Okay. Now the question comes. The next one is called normality. This is the last part, or I will say equivalent. Okay. So what happened is, if you give one sodium and one chloride, when it mixed it, what is the equivalent of sodium and what is the equivalent of chloride? When we say sodium chloride, 23 grams plus 35.8. But sodium is 1, chloride is 1, Na and Cl. Why don't we take 1 gram of sodium and 1 gram of chloride? We don't take, right? Say example I'll give you. In NaCl, why don't we put Na plus Cl? Na is equal to 1 gram plus Cl is equal to 1 gram. So why don't we mix this way? In the formation of NaCl, it is 23 grams sodium is mixed with 35.5 grams of chloride. Why different form? Why it is different? Why not 1-1? Even though it's written here 1-1, correct? Just listen to the story. Another one is, very simple thing is, say sodium sulfate, or say calcium chloride. Calcium and chloride. Calcium chloride formula is 2 because calcium valence is 2, so it's mixed with 2. This is calcium is mixed with one chloride and another chloride. Am I correct? Calcium chloride. So why don't we say 1 calcium plus 2 chloride? So 1 gram of calcium plus 2 gram of chloride. Why don't we say like this? No, this is not correct. Okay, the reason is, or here, what we say is, in calcium chloride, 40 grams of calcium plus 2 into 35.5 grams of chloride. Here it is 1 calcium, 2 chloride. But over here, 1 and 1. This thing is going to come. I'm just giving you some fundamentals. Why such things are happening. So, in order to make the things very clear, how many grams of calcium is mixed with how many grams of chloride? Or how many grams of sodium mixed with how many grams of chloride? We bring the concept called equivalent or normality. Okay. Another very example is, if I say, can I say like this, 1 rupees plus $1. Can I say 2? No. So this is 1 rupees plus dollar maybe 75 rupees is equal to 76 rupees. Right. This is the equivalent. So you have to have the uniform weight. The reason is, when the chemicals they react to each other, they reacted based on the equivalent. Okay. So based on the equivalent, and in another way, you may be remembering that what is 1 mole of a substance? 1 mole of a substance, something equivalent to 1 by 12 of carbon, and that is equal to Avogadro's number. And Avogadro number is a fixed number of quantities of the ions, right? So the terminology equivalent comes in the picture right now. So then what is equivalent or what is normality? Then I'm going to come. Okay. More than I explain, the more I have to rough. Okay, now you see over here, in terms of equivalent, what happened is one equivalent is equal to one molecular weight divided by its reactivity. Remember this. In some terminology, reactivity people define as valency also. Okay, so one equivalent, or I'll say one normality, is equal to one molecular weight divided by Z. Z is the valency or reactivity. Is that okay? So one normal of calcium. Calcium molecular weight is, I told you, 40 grams. The reactivity of calcium is 2. So it's equal to 20 grams. So if you dissolve 20 grams of calcium in 1 liter, that is called one equivalent of calcium or one normal solution. Okay? In 1 liter. This is one normal solution of calcium. Is it okay, clear? Fine. Now, what about one normal of sodium? Sorry, for sodium, valency is 1, so it is 23 grams divided by 1 itself is 23 grams. So from here, I'll conclude that for all the monovalent ions, single ion, that is chloride, sodium, potassium, for all such monovalent ions, the equivalent and the molarity both are same because the reactivity is 1. So it will be same, okay? But whereas not for divalent ions. Another example I'll give you, magnesium. Magnesium molecular weight is equal to 40 grams. Sorry, 24 grams. So one mole magnesium is equal to 24 grams dissolved in 1 liter, whereas one normality or one equivalent magnesium is equal to 24 divided by 2 is equal to 12 grams per liter. So this is half. 1 mole is equal to 24 grams per liter, but one normality is equal to 12 grams per liter for magnesium. You have to remember this. Is it clear? Is it okay? Fine. This is all about normality. Okay. This cloth has also covered all the paint. Okay. Now, you may have done a lot of titration for estimation of ions. Let me give you one example. How do you prepare 0.02 normality of sulfuric acid? We always say alkalinity is titrated with 0.02 normality of sulfuric acid. How do you prepare? You see, 1 mole of sulfuric acid is equal to, hydrogen is 1 into 2 plus sulfur is 32 plus oxygen is 16 into 4 grams per liter. 32 is 34, 34 plus 64, 60, 90 is equal to 98 grams per liter. Okay? So 1 mole of sulfuric acid is 98 grams per liter. Therefore, one normality, excuse me, one normality is equal to 98 grams divided by valency, that is 2. It's called 46 grams per liter. This is one normality. Is it okay? This 2 is, I'll say, the reactivity or the valency. Okay. So it is 46 grams per liter. Therefore, 0.02 normality sulfuric acid is nothing. It is 46 grams into 0.02 grams per liter. So 46 into 0.02 means 2.46. 0.46 into 2. That is 2 6 12 to 1 kg, 2 4 8 9. I think is it going to be 9.2 correct? 0.46 0.46 into it is going to be 0.92 grams of sulfuric acid per liter. This is 0.02 sulfuric acid. Okay, is that okay? This is concept. So this is all about the things. Now the last part, let me give you one more basic fundamentals. After that, I'm going to come for chemical balancing. Okay. These are almost, this one comes exactly for the exam, but these are all the basic fundamentals, little part of the chemistry. Okay. Now, when we try to define alkalinity, I'm just giving an example. I'm not going to teach alkalinity right now. Alkalinity is due to the presence of OH ions, especially CO3 2 minus and HCO3 minus. Another one is hardness. We say hardness is due to the presence of calcium and magnesium, right? So what happened is we have a lot of these three ions combined. OH ions have molecular weight of 16 plus 1, 17. This is 12 plus 16 into 3. This is 1 plus 12 plus 16 into 3. This is, so none of them have the same molecular weight and none of them have the same equivalence. So they cannot be mixed up. So for example, this is in terms of rupees, this is in terms of dollars, this is in terms of pounds, and you cannot mix it up. And you cannot say the total alkalinity is this much. You cannot say. Okay. So what we do is we convert everything into in terms of equivalent. One equivalent of one example, one equivalent of OH will be equal to one equivalent of CO3 2 minus. Because equivalent means it is a general accepted value because it contains same ions amount. Okay. So OH means O is 16 plus 1. So 17 grams of OH will be equal to, what is CO3? 12 plus oxygen is 16 into 3 divided by valency is 2. So this is 3 6 is 18, 3 1 is 3, 48, 4 50 is 60. Is it correct? 48, 4 50 is 60, 60 by 2, 30. So 17 grams of OH is equivalent to 30 grams of CO3 2 minus. Okay? Is that clear? See the value 17 and 30. It's not same. So my point is you have to convert everything into in terms of equivalent. Okay. Now I'll give you one example. This alkalinity, if I say OH seems to be, say, 20, if you mix 20 milligram of OH, this one you make, say, 30 milligram, and this one you make it around, say, 40 milligram. Can you see the total alkalinity is 40, 70, 90 milligram of alkalinity. 90 milligram alkalinity. I cannot say this is not correct. This is not correct. You have to convert the equivalent of this, equivalent of this, equivalent of this. Okay. So let me tell you this concept also. See over here. This OH number one equivalent of OH is equal to 17 grams because 16 plus 1, 17 divided by 1 is 17 grams, correct? Therefore, 20 milligram is equal to how much? 1 by 17, this is gram, this is milligram, into 10 to the power 3, right? Into 20 equivalent. Am I correct? Is that okay? 20 milligram, this 20 means this 20. So it's equal to 20 by 17 into 10 to the power minus 3 equivalent. 20 by 17, it will be 1 point something. It's equal to 1.17, 10 to the power minus 3, can I say milli equivalent. This is number 1. Okay? This is number 1. What about 30 milligram? 30 milligram of CO3 2 minus. 30 milligram is equal to 1 equivalent of CO3 2 minus is equal to C is 12 plus 16 into 3 divided by 2. This is 45, this is 30 grams. Okay. Therefore, 30 milligram of CO3 2 minus is equal to, then can I say 1 by 30 into 10 to the power 3 into 30 is equal to 30. 30 is cancelled. So this is 1 milli equivalent. This is equation number 2. Equation number 2 means this is 1, this is another one. This one is this, and this one is this. Okay? Is it clear? Number 3rd is 1 equivalent of high CO3 minus is equal to 1 into 12 plus 16 into 3 divided by 1 because valence is 1. So therefore this is 61 grams. Okay? Therefore this is 40 milligram of high CO3 minus is equal to 1 equivalent is equal to 1 by 61 into 40 milligram. This is 10 to the power 3. Sorry, 40 equivalent. So this is 40 by 61. 0.66, 0.66, I'll say milli equivalent. Is that okay? Let me check whether the video is still on or not. Sometimes, fine, video is still there. So you can have these 3 values. Okay, now this 90 milligram per liter is not correct, but this is rather 1.17 plus 1 plus 0.66 is equal to 2.83 milli equivalent. This is the correct answer. Okay. Now the thing is, when 20 milligrams of hydroxide and 30 milligrams of CO3 2 minus carbonates and 40 milligrams of bicarbonates, they've added, the answer is 2.83 milli equivalent. Okay. Now, milli equivalent means it is a universal concept. But now the thing is, you said, sir, what is milli equivalent? So to make the things very easy, this 2.83 is not OH alone, it is not CO3 2 minus alone, it is not HCO3 minus alone. It is a combination of all these three. They mix in the right proportion. Everything we converted in terms of milli equivalent. Okay. Now finally, what we will do is we'll combine it. What we do is say it is just like $1. It's just like you're getting dollar plus, how do you write? I don't know, pound plus yen. Japanese, European, and American. Okay, these three we are converting in terms of milli equivalent. So what we do is we try to convert this one in terms of rupees. Okay, example is there is a thing called an iron which is very very funny. It is called calcium carbonate. The molecular weight of calcium carbonate is calcium is 40, carbon is 12, oxygen is 16 into 3. You will get 100 grams. And one equivalent of calcium carbonate is equal to 100 divided by 2 because the valency is 2 over here. Right? So this is 50. So this 50 is a numerical value that is very 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 easy to calculate. So one equivalent of calcium carbonate means 50 grams. Okay. So therefore 1 milli equivalent of calcium carbonate is 50 milligram. Very simple. Is it correct? So what we do is that this milli equivalent we continue with 1 milli equivalent of calcium carbonate is 50 milligram. Okay, so this can be converted as 2.83 milli equivalent. 1 milli equivalent is 50, so it is 50 milligram of what? Calcium carbonate. So we use the word as calcium carbonate, not calcium carbonate, calcium carbonate. 028.3, 5 3 is 15, 1 carry, 5 is 40, 1 4 carry, 5 2 is 10, 14. So milligram per liter as calcium carbonate. So when we try to express the alkalinity, we use the word S. Okay. So 2.83 milli equivalent is very similar to 1.415 milligram per liter as calcium carbonate. But this doesn't mean to say that your water or the wastewater contains calcium carbonate. No. It may contain, it may not contain, we are less bothered. The thing is 141.5 milligram per liter equivalent of calcium carbonate is a total alkalinity. That is concept. Okay. So similarly what happens is when they say the water contains hardness. Another example is they say the water contains hardness. Okay, in the hardness, if I say calcium is 28 milligram and magnesium is say 16 milligram, then what is the total hardness? Hardness, we know it is the inability of the water by the detergent to make froth, the bubbles. Okay, so that difficulty is due to the presence of calcium and magnesium. Calcium present is 28 and magnesium present is 16. But what is the total hardness? The combination of these two is going to give the degree of the hardness. Can I say 4 milligram? No. So what we do is that since it contains two or more ions, we convert it in terms of calcium carbonate, equivalent formula. So number one, what is calcium 28 milligram? One equivalent of calcium is equal to, calcium is 40 divided by 2, because valence is 2, it is 20 grams per liter. Okay. One equivalent of magnesium is equal to 24 molecular weight divided by 2, because valence is 2, so it is 12 grams per liter, right? So 28 milligram is nothing, it is 28 divided by 20 milli equivalent is equal to 28 1 jar 0.4, correct? 2 by 2, 2.4 milli equivalent. Number one, this is number one, and this 16 milligram is 16 divided by magnesium is 12, so 12 milli equivalent. This is 16 by 12, 12 1 to 12, 0.40, 12 3 to 36 milli equivalent. Okay, correct? So you have two values over here, 1.33, 1.4. Therefore, total is 1.4 plus 1.33 is equal to 2.73. 2.73 milli equivalent. Okay, is a total hardness. So this is therefore total hardness is equal to 2.73 milli equivalent. Now we have to convert 2.73 into 50 is equal to 27.3 to 5. 5 3 is 15, 5 7 is 35, 6 3 into 30. 136.5 milligram per liter as calcium carbonate, because this 50 is this one, correct? So total hardness is 136.5 milligram per liter is calcium carbonate. So these are some of the basic fundamentals of how to combine the milli equivalent, the equivalent, the combination of different atomic molecular weight, the molarity, all these things. So from the beginning, let me again remind you, for the basic environmental engineering, number one, you have to know the basic units of the concentration. The first is milligram per liter, very simple. Second is ppm. I describe in such a way that you'll find very difficult to forget. 1 ppm is equal to 1 milligram per liter. Third, percentage. 1 percentage is equal to 10 grams per liter, or you can say 10 to the power 4 milligram per liter. Therefore, 1 percentage is equal to 10 to the power 4 ppm. Okay. Number 4 is your molecular weight concept. Before knowing the molarity concept, you have to know some of the molecular weight of common compounds. In environmental engineering, carbon, hydrogen, oxygen, organic compounds. Carbon 12, hydrogen 1, oxygen is 16. Fine. Nitrogen, phosphorus, nitrogen is 14, phosphorus is 39. Phosphorus, I have a doubt, it's 39 or 32, I couldn't remember exactly. Then chloride 35.5, hardness calcium, magnesium, calcium is 40, magnesium is 24. That's all, right? The next part comes your molarity concept. One molarity of a substance is nothing. It contains one molecular weight divided by 1 liter. That is dissolved in 1 liter. Okay, so sodium is 23, chloride is 35.5. So 58.5 grams you dissolve in 1 liter, you will get 1 mole solution of sodium chloride. Simple, finished. Next is to make the chemicals mix together. There is something called reactivity. Say for example, I have two hands, I can dance with two peoples. That is my reactivity. Some person, little bit handicapped maybe, I shouldn't say, they can hold only with one hand, then their reactivity is one. So similarly, calcium can combine with two peoples. Sodium chloride can give only one hand. Okay. So similarly, this way in anionic sulfate SO2 minus 4 minus. Sulfate can combine with two positive ions, whereas chloride negative ion can combine only with one. So because of the reactivity, this concept is also not giving proper picture, the molarity concept. So we come to the concept of equivalent, or we call it normality. So normality is nothing, or equivalent is nothing. It is the molecular weight divided by the reactivity. Reactivity is a very good terminology, but to make the things understand to us, we call it valency. But actually, it has different meanings if you go in depth chemistry. But for environmental engineering point of view, reactivity, valency is almost same. Okay. So now the next part is sometimes some of the physical, chemical, especially chemical parameters in environmental engineering, like alkalinity, hardness, they constitute of more than 2 or 3 ions. Alkalinity is responsible by hydroxyl ions, carbonate ions, and bicarbonate ions. And none of the three have same equivalent. So just now I told you how to convert everything into equivalent, combine it, correct? For the hardness, the presence of calcium and magnesium, none of them, both of them are not equivalent. So we convert them into equivalent, correct? Now we got the answer of the alkalinity in terms of equivalent, hardness in terms of equivalent. Now the question is, then what is the unit? We cannot give it an equivalent. We convert it in terms of calcium carbonate because the molecular weight of calcium carbonate is 100, whereas the equivalent is 50. So this is an ion. Very funnily, from mathematical point of view, its multiplication factor is very simple. Molecular weight is 100. It's 50. So it's very easy to calculate. So people make it as a standard unit and we try to convert everything in terms of calcium carbonate. If the parameter, chemical parameter have 2 ions or 3 ions or more, like hardness or alkalinity. So alkalinity, we cannot say it is due to the 1 ions. It is combination of 3 ions. So 1 milli equivalent of calcium carbonate is 50. Therefore, if the total is 2.73 milli equivalent, this milli equivalent you must make it 50 milligram. But the answer should always be SCO3. The word AS is very, very, very important to mention that the meaning is, this is to simplify that calcium carbonate may be present, may not be present, but we are converting in terms of calcium carbonate. That's why we always say S. Okay? So now let me wind up because the video is getting more than 35 minutes. Let me continue with another, what you call your balancing the equation. If I continue the balancing the equation, then it will be too much. So this class I completely dedicated to the basic fundamentals environmental chemistry of civil engineering MTech. Okay? Thank you.